Okay. Homework questions. What do people want me to do?
Can we do number 4 on our test calories? I'm struggling with that.
Turn-in problems?
Yeah.
Okay, so
I think that's
homework, turn-in, calories. Whoops. 4. Okay. We're going to need the fact that she has some of this stuff. So I'm going to copy this part first. Mostly we want this part. Okay, and I should give us a header at the top. So we are in health decisions. Calories, turn-in homework. Okay, good enough. So how do we know how many calories she burns walking?
Do we do the 0.60 times 30?
Times 30. No, we don't want 60% of her minutes. We want 60% of the calories. Whoops, I didn't hit share all the way. One moment. There we go. That's better. Okay, so let's open a new
So 60.
math window. So we wanted to find out how many calories she's burning from exercise. So we had this table, remember that?
Yeah, I think I tried this, but I think I used the wrong number.
Okay. My screen is getting much too full here. Okay, so for walking, that's 0.037. So we take that 0.037 and we multiply it by her weight. So the fact that she, not weight, I'm sorry, 120 pounds. And we also multiply it by the time. So our time is 30 minutes of walking. So 0.037 times 120 times 30, I'm getting 133 calories.
It's like 133 point.
And I'm rounding because, again, all of the health stuff isn't accurate to 1% anyway. Okay, so of that, some of that is fat and some of that are carbs. We talked a little bit the other day about when you're working harder, you're burning more carbs because your body needs short-term energy. When you're exercising at a more leisurely pace, you're burning more fat because you're using your long-term energy storage. So Now we're going to the 60% part. So 60% of the calories she burns, so it's 60% of that. So we're going to take that 133 multiply it by the 0.6 that you mentioned earlier. We get about 80.
Okay.
So 2 steps. We have to first find how many she burned total of both kinds. And then we have to say of those.
Okay, I thought I got that wrong.
Okay, good question. So, other questions. We've done all of health decisions. Any questions you have on example problems, on random problems, on turn-in problems?
Just a sec.
Okay. I'm going to put that one there so people can see it if they need.
Can we try number 9 on calories?
Number 9 on calories. Oh, okay. Looks like we have to do number 8 first. Because for number 9, we need to know how many grams of sugar are in the chocolate. Okay. So from here, we have 10 grams of sugar per serving. How do we get from grams of sugar to calories of sugar?
We times it by 4.
Yes. Sugar is a kind of carb, and carbs were 4. So he has 4 servings. So if each serving is 40, all 4 is 4 times that, and we get 160. Everyone okay with 8 so far?
Yeah. Yes, thank you.
Yeah.
For 9.
Yes.
Oh, no, I have confused myself, just like I did office hours time. We don't actually need the calories of sugar because he's talking about grams of sugar. So all we really needed was that there's 4 times 10 per grams. So 4 servings. But it's good that we did 8 too, I suppose. So that's what we needed. The other part was just extra. So we want to say 40 grams is what percentage of 63 grams. So we do our little Mad Libs thing. Remember that game for percents? So I need to have a what and 2 numbers. What goes in my spots?
Why?
I don't want a y yet. I want either the
40.
word what or the 40 or the 63.
40.
40.
CC.
What?
That's the thing we don't know, the what percent of 63. So just to review, this one was the part, if this one is the whole, or maybe this is the new, if this is the original. Something like that. So when I translate it, I'm going to get 40 is becomes equals, what becomes y, of becomes multiply, and 63 stays there. I have something with times 63 stuck onto y, so I'll do divided by 63. Whatever that is. So about 0.63. That's humorously consistent. Oh, okay, so that's what we get. So it just so happens that 63 grams per day and the 63% of the answer are 263s, but that's just a coincidence.
It makes you think, though.
Yeah, I could always change how much sugar is in the chocolate so it doesn't come out so nice. But yeah, 160 calories isn't a whole lot. If that's like a bunch of his dessert throughout the day, he's not eating badly, but he's used up most of his sugar for the day with that. Okay, good questions. More homework questions. Any of our health decisions topics? Random problems, turn-in problems.
Could do number You want
Which number?
5 on our turn in?
5 for the calories again?
Yes.
Oh, okay. Okay, so the 1 cup serving of milk has all those things. So we want 3 cups, so 3 servings. And we want fat. So 1 cup. So fat was the 5 grams. How do we change that into calories?
By the fat.
Yeah, fat was the one that was 9. So 120, 130, 135. Am I my mental math right? Oops.
135.
Is that what you got?
Yes.
Okay. That's a lot of calories. Questions on metabolism or food preparation? Uh, None yet. Okay, so if no one's having questions on metabolism or food prep, then I will make a note that those will be due when I see you next. Did
So
calories have a due date yet?
I thought they were due today.
If
What?
it didn't, that's okay. It can be due later than the others. They can be due out of order.
I got some other homework done. I didn't get
Sure,
the,
which ones?
I got the book ones, or the text one, or the page 9 and 299.
Okay,
Which
in the
one's
blue
done?
book or the online book?
Yeah, the text one online.
Online. Okay, page 90.
Page
Oops.
9 and 299.
You're cutting out. I'm sorry. Tell me if I'm hearing you wrong.
9 and 299.
99?
Yeah, just 9.
Page. I'm still having trouble. Page 9?
No, I didn't have any trouble at all.
Okay, which one?
Huh? Oh, I got what you've listed on there, your homework thing to get done. I got that done in 299. So I got some of these done.
Okay. Okay, let's go back and see here.
Pretty much like a review of what I did in Math 20.
Okay, so reviewing Math 20.
Or, well, yeah, this one. Pretty much what I did in
Okay,
Math
so
20.
if you haven't seen this before, then if you go to the homework page and scroll down just a little bit, then if you want to review your Math 20, then these two links are sort of the best homework problems so my Math 20 students don't waste their time. This is completely optional for you as Math 25, but if you want to do some review, then you're welcome to do this. So what she's seen is that some decimal stuff had review on page 9. So that's where I'm getting this list from. So again, not part of Math 25 officially, but if you need some review, then this is one way to do it. Okay, which problem?
Oh, well, okay. I was thinking that was our homework, so I did that, some of that.
You did that. No, I can still do one if you want.
Okay, well, I had a hard time looking for our original homework.
Yeah, the only homework you're supposed to turn in is the one that says turn in down here. And then skip shape-shifting, mad science, and justice, because we are starting with health decisions.
Okay.
The first homework you should try is start at the top of the page. It says first go to the math topics and look over what we did in class. Make sure you could do the example problems yourself without me there. And then skip the problem bank for now. That's only Math 20 right now. Then you have random problems, and random problems are great. That's what will be on the test. Again, skip the 3 topics from 20 and start at health decisions and say, here's some random problems to do. You can check your work. Once you've done enough of these that you're feeling very confident, then go down and try the turn-in problems for whichever our topics are. Make sense?
Okay.
When people want me to do some video things, I think I said this at the very beginning of the hour, that I'm happy to record some things for the problem bank, but right now there aren't any for Math 25. So focus on the random problems and the ones to turn in after you've looked at your notes. Okay, anyone want any place value problems while this is opened?
No, I pretty much got everything except for maybe 1 or 2 problems, but other than that.
Put something in the chat here or something like that if you want me to do one. Okay, I want to do an announcement-y thing first before we move on to any new math material. So Math 25, as I mentioned, is both very real and very fake at the same time. When we look at any of our topics, then the specific things that we do are on the job done usually by computer programs. If you are in the restaurant industry, then you aren't going to do yield percent by hand with a calculator. You're going to have a computer that tells you how much to shop for if you need this kind of recipe for food preparation. Or if you're a personal trainer, you're not going to have to take out your calculator for those health formulas. You're going to just have a little app and it'll tell you, for this client, then they should be having this kind of exercise heart rate and so on. But at the same time, you will have to do certain kinds of math on the job, and they will be not really any easier or harder than what we do. So by jumping through these hoops, you're not only understanding your job's tools better when you get there, but you also have kind of proven that whatever does come your way, you can handle. When we get to personal finance decisions, there are lots of websites that give you good mortgage numbers. You don't have to do all that by hand with a calculator. But again, if you do it, then we know you can. We know you understand what's going on behind the scenes with those mortgage discussion websites, and whatever else you have to do for personal finance, we know you can handle. The same thing with pricing, right? If you're running a food cart, working at a retail store, you're not going to do things by hand as much. They'll have some software to help you, but whatever you do need to do, you've proven you can do it, and what the software is doing in a more automated way, you now kind of know what's happening behind the scenes. So this is all good stuff, but it is kind of fake and real at the same time. What the people wanting you to take 25 also want is this stuff down here about being a mather. And I don't normally just read out stuff from the website too much, but this one I will, because it is carefully written. And so people know if they're a reader, right? My kids know they're readers. People say, you have learned to read, good job. Or you want to know more about grasshopper mice that kill giant bugs and howl at the moon, go read about that, or something like that. There's no English word that means a mather. It's similar to a reader. And why not? What's different with math? What's different with the English language? What does it mean for you to be a mather? One thing is that for some reason, even though we know that you read and write at different levels, the kind of language you produce is different than the kind of language you consume. For math, most math classes, they stick you with, if you're going to do this math and read about it, you also have to put it out. You have to produce and consume at the same level, which is very artificial. So we have a class library with all sorts of good books, even more if you were to click on them, that they are math books, but they're not math textbooks. They don't have sections with problems at the end. They just have interesting things about the world that math helps you explain. You can consume these at a higher level of math than you could produce yourself, just like you could read a great novel even if you're not a novelist, or you could read a nice poem even if you're not a poet. So in a normal term, I would have all of these in a cupboard in the classroom and you could take them home. But today I'm going to head to LCC, grab them from my office, and if you want to do any book reports this term, then we'll figure out how you can swing by someplace, and I'll go to a park and play Frisbee with my kids. Well, you stop by and get a math book from a card table 10 feet away or something like that. So another difference between math and English is that when you are good at advanced language stuff, people say, well, that's your hobby, or you're eccentric, or you have some sort of academic specialty. Whereas no one is expected to sentence diagram stuff or read Old English. Math, it's sort of expected that you're following this bizarre flow chart, and you don't get to call yourself good at math till you've gotten a certain distance on the flow chart. But that's not how math really works at all. You have all sorts of different branches of mathematics that don't really connect to each other, and you can enjoy, you can enjoy some of those without having any skill at the others. So the fact that people haven't shown you some of what these things are is very strange. That would be like having all your language be about novels and nothing about essays or poems. Another reason that math and English are different is that math classrooms tend to ignore the real math that people haven't done before. Instead, we give you a book that's full of problems other people have already solved and say, focus on this, which is much more like an art appreciation class than actually painting. So we want you to make your own new math. So here's how real math works, that you have some real life decision. We need to make a decision. What should we do? Should we rent and buy a house? How much food should we buy? How much money should we save? Something like that. We have to pick some relevant amounts to estimate. And usually we don't know exactly how much the utilities will cost. That changes from month to month, or how much the cost of this food will be, because it might change before we get to the store or so on. So we pick some things and we sort of know the numbers, but not exactly. And we move them around on paper a bit. And then we have to see, does this work? Is it trustworthy? Can I actually make a good decision based on this? Or have I just moved a bunch of numbers around on paper and I can't trust the answer because I estimated so much? And at the end, we normally communicate with others. Maybe we're living by ourselves and no one else cares whether we rent or buy a house. But usually in most decisions, there's somebody we talk about with it. So what it really would mean to be a mather, if this was a real word, was, can you participate in a math discussion? Can you enjoy a book that you don't actually have to make any math about? Can you explore branches of mathematics other than the ones that are normally taught in classes? Can you look at issues and problems and help make decisions? Can you use resources to refresh any rusty skills? Can you do problems when you need to do problems? And can you plan how much math will be in your life? So when I look at our grade book, those are important things because that's kind of what it really means to use math. So far in the class, we've started simple. We've dealt with the topics, we've dealt with the homework, and you've gone to the lecture note page and you've seen all of our online lectures we've done, including from the study session. So now we're sort of going to move down a bit. In the library, we have not only all those books I mentioned, but there's ebooks and podcasts and apps and other open educational resources. So start looking at that. Nothing is assigned right now, but you have many days until I see you again on Tuesday. So take a little bit of exploring the library. The playgrounds are things that don't really have one right answer. So you can play with different kinds of math that you might not have seen in the classroom before, like graph theory, or exploring patterns this way, or beautiful mathematical ideas. Things about how errors make answers not trustworthy. So that's for that kind of being a real math thing. The start of term reflection and core learning outcome reflection are optional for you. That's there for the Math 20 students, but it's not a bad thing to look at. This isn't a syllabus quiz. I'm not asking you a dozen questions and asking you to answer them. It's just sort of get your brain organized as we're starting the class. Like if you're packing for a road trip, do you have the right stuff in your car? Because we've kind of gotten going. The thing you care about a lot in Math 20 are the big issues. So here we have all sorts of questions with no right answer. So use some of the health decision formulas for yourself, or do some research about the BMI and body fat formulas. I told you that they're a bit suspect for being used with individual people, so find out more about that. Or find out about blood oxygen level. That's a math number that the doctors use that we haven't talked about yet, so learn about that. Or take some of the food preparation stuff we've done and make your own meal plan and so on. When we get to other things like personal finance decisions and business decisions, there's things here, but you don't have to wait till we get to this in the class. You can read about the contract cheating industry for how people cheat on college tests without having actually waited till we get to business topics in the Math 25 class. So I would also look through these a bit over the weekend. And what I would like to do is on Tuesday, just sort of go around the room and because now the little poem about Canterbury Tales Old English, the point is that you have to really study English specialty to understand that. Yeah, it is supposed to be confusing. Anyway, so what I'd like to do is on Tuesday, go around and have everyone just share which of these they're most interested in. Pick 2 or 3. So they don't have to be ones you're committing to do right away, but there we go. And if you have something that's not on this list, let me know. Maybe you're planning to build a doghouse, and that would be a good use of some practical math, and you want that to be one of your big issues or something like that. So I will remind you in the homework after class, spend some time kind of looking at the playgrounds, but more importantly, picking out which big issues you want to do. Then when we have the grading, then all of that happens. By the way, does anyone need a refresher on how to use the code names and the go button while we're here? Let me just point out that if you do pick your code name and hit go, these links still work. You could jump right to homework and see which check marks you have. Okay, so I'm going to talk about the letter grade stuff in a moment, but skipping it for now, then here's the how real math works things. And some of this you've already done. If you were at the study session, then you probably have already worked with a classmate who asked for help. So let me know when you get these stars. I could notice myself perfectly and put them in the grade book, but I would rather you tell me in class and then we can all sort of celebrate, or you tell me in an email or things like that. The big issues we just looked at appear twice. Just starting them, only beginning them, gets you some stars, because putting some real life issues on paper is in itself something worth learning to do. And then if you solve up to 6 of them, you can get a ton of stars. You don't have to actually do 6 this term. This is for the very ambitious people. Again, some people have done a problem.
David,
What was your question?
if we notice that the news is using like patterns and percents and fractions right now,
Yep.
how do we get that to you for our start?
If it's a newspaper, take a picture of the article and send it to me. If it's online, just send me the link.
Okay.
Some of you have done a problem on the board during class, during our study sessions. So if that's you, then let me know and I'll check that one off. Teaching someone else, again, some of you have done that already at the study session when you helped each other. Then the being math or also includes things like asking a question during a class. So Elizabeth and Donna have done that already, so I should check them off. Why don't I even do that right now? So question. So maybe by the end of the term, you'll have asked 11 questions. Right? I think Donna asked 3 or 4 today already. Attended a study session. Some of you have done that. Let me know you were there, and so on. So you'll start getting these check marks on your stars pretty quickly. The first part of the library is the first chapter only of Factfulness is available for free on the internet. So you can read it, see if you want to read more of this book, and get a star just for summarizing it. So that's something you could do this weekend. Again, 2 of the explorations about other kinds of math topics, things like that. Someone asked me, do you need to write things out neatly? And when you turn in your homework, and the answer is no. What you do need to do is, where is it? There we go. For only 3 of our topics, turn in a page of homework. So take a picture of your written work that has all the 16 characteristics of well-written problems. And what those are, I can talk about, but I probably don't want to right now. They're listed here. They're things that most of you do anyway. So there we go. But you don't have to show me your written work for every homework. Just the code is enough. Only for 3 homeworks do you need to write nicely. Okay, so your last thing to sort of play around with over the big extended time before I see you on Tuesday, it's not a long weekend because we all have jobs and kids, but math-wise it's a long weekend, is to look through this and get a sense of what tasks you've already done and send me an email about them and what things you will do and sort of plan out your term. The last 2 I want to highlight are that most of the time, a plus or a minus after a letter grade doesn't mean anything meaningful to anybody. Some employer that you're applying for a job, some teacher for your next math class, if you got a B plus as opposed to an A minus, they have no idea what that means. Did you have a headache and a bad day on the day of the final? Is your teacher grading in a certain way? Who knows what the plus or minus means? So part of using the star system is that we can actually communicate useful information with a plus or minus. So that modifies your grade by how active you are in the class. So remember I said that you don't need to do 6 different big issue questions. You could just do a few. But if you get more stars than you need, then you get a plus after your letter grade. If you have 4 late homeworks and you don't have that plus, then you get a minus after your letter grade because you've been falling behind. So you can turn in 3 homeworks late out of 12 and have no penalty at all, but don't turn in a 4th one late unless you're going to get a plus, or if you just don't care if you get a minus after your letter grade. And if all you want to do is, pass the class, then you can turn in all your homework late and still pass the class. But that you don't want to turn in homework late. Don't fall behind. It's risky, especially when we have kids and it's still flu season and things like that. So, okay, questions about all of that announcement-y stuff. That was a lot of me just talking about the next row on the
Sorry,
website.
you only get a hand in three of them late. 3 homework assignments late.
Yeah, you can turn in 3 late without any problems.
Okay. Well, I'm sorry I'm late on this first one, but so do we just take a picture of our work, right, and send it in?
I'm sorry, your mic is
I
still.
tried to print the syllabus last night or the other night. And we just take a picture of our homework, right? My printer messed up the part where.
I'm sorry, I shouldn't have muted myself. Can you type it in chat? Your mic keeps cutting out. I can't understand what you're saying, Elizabeth.
I know. It sucks.
Okay, now it seems working. Tell me again.
Oh, I was just asking how do we send in our homework? Just take a picture of it?
Your homework, you're going to send me a code. Let me go over that then. So once you've done the practice with the, come on.
Oh, I mean, because I did mine on paper. Or I wrote down like.
So yeah,
My computer was messing up, so I had to screenshot everything on my phone so I can blow it up and look at it. So I wrote everything down.
okay. Yeah, normally if you want to turn in, say, the metabolism homework, you just do this thing with the code. Do you need me to review how that works?
No.
No, okay. For the 3 out of 12 that you want to get, yes, I've written them neatly, then you'll need to show me your actual work. So take a picture of it with your phone and send it to me.
Okay, that'd be cool.
I don't need to see your scratch work for all 12.
Sometimes it's hard to, like, I don't know, get my computer up sometimes, and like, because I have to blow up the screen on my phone in order to look at it, so I have to screenshot it because it won't let me blow it up on my phone. So I have to screenshot it and look at my screenshots.
Yep. Well, you and Misha wanted printouts. So today, when I finally can go to LCC, I will get printouts. So that can help you.
Okay.
Okay. Other questions about any of that? As the term goes on, you're going to use your achievement list more and more as a to-do list, which is why it has links. If you go down to the bottom, then if I want to turn in my metabolism homework, then I can just click right here on turn in homework, and there it is. If I want to look at the lecture notes, then I click on the word metabolism. So this is designed to be sort of a table of contents as well as how you're doing. And it's kind of fun once you start getting these check marks rolling in. Okay, I think that if no one has more questions on that. Oh, I had one more question for you. Let me stop my share. So the Math Resource Center has right now 2 kinds of tutoring. There was the online tutoring where you have like a Zoom room and set up an appointment and have some one-on-one chat with somebody. And then they have email tutoring where you can just email them questions, which isn't quite as nice, but works any time of day. They're planning on doing a text chat, like some sort of customer support for a utility company where you can chat on text with somebody, but they don't have that yet. So I'm just curious, has anyone used the Math Resource Center yet this term? How did it go? Is their system working well?
No, I've mainly used your resources.
Okay, well, you can use only mine, but they are there too. You might want to stop by just to let them feel useful. I'm curious how it's going for them. Okay, well, let's start more math. So we've done all of the health decisions, and these again were the straightforward formulas. You know what to plug in, you plug everything in, you get your answer. That's why we breezed through this so quickly. So we still have formulas in personal finance, but now they have some context. It's not always as clear which formula to use. Although once you know that, then you can plug things in. So let's look at just an overview, an overture of what's happening. We start by talking about typicality, because if we say things like a typical family is trying to save this much for retirement, then we want to know what we mean by typical. We're also going to talk about different kinds of averages, if you've heard of mean and median and mode. A lot of things about money deal with bell curves. So we're going to talk about bell curves as their own topic, and what bell curves are, what they're useful for, what they're not useful for, how people try and use them in ways they're not supposed to be used, and so on. And once we have those two sort of background issues done, then we can actually talk about the money itself. We'll start with mortgages. How big a house can you afford? And we'll get into a tangent at the end about bank safety, because we had the recession happen in 2007 about the mortgage crisis. So we can learn to understand that a little more.
Share your screen again.
Whoops, I'm sorry. Thank you, thank you. Let me start that list over then. Okay, everyone see my screen?
Yes.
Okay, so typicality. What do we mean by a typical person or a typical family or a typical retirement plan? And the words about averages. And then the bell curves, what they're good for. So mortgages, we really talk about money. How big a mortgage can you afford and what happened to banks? Why there was a crisis. And then saving for retirement. We're going to do some review on percent sentences. We're going to talk about both simple interest and compound interest. And then we're going to talk about things like rent and how much you need to save for retirement. So that's our personal finance topics. What else do you want here from the intro? As always, make good notes. All of our tests and homework are open notes. If all you have is a giant pile of papers, that's not going to help you, because you'll have to spend all your time flipping through them. So get some sort of efficient, organized notes if you can. Mortgages are complicated only because they have lots of steps. So that will be something that will, just heads up for that. So for all of our formulas haven't really had steps to them. And yeah, I guess that's all. Okay. I've shown you the headings map thing before, so that's what this little bit is about, if you like having that. Ready to talk about typicality?
Yes.
Yes.
Okay.
Yep.
So pattern blocks are these toys here. If we were in a normal class, I would take out a tub of them and you could all play with them, but I can't do that online. Is there anyone that's never seen them before? These plastic or wooden blocks?
I haven't.
Yeah, okay. I could go down and get my tub of them, but that wouldn't really help you. So there's a green triangle. It's the smallest. And you could see if I had 6 of them, I could fill up this hexagon shape. If I have 2 green triangles, I make a blue diamond. If I have 3 green triangles, I make a red trapezoid. If I have 6, I make the whole yellow hexagon. And you can do lots of things with them that we don't care about. So for now, our question is just that if I was to weigh it and find out that the green triangle weighed 1.5 grams, and then someone else said, here's a group of things, and they asked, what's the typical weight of a block in this group? That seems like a reasonable question. What's the typical weight of something in a group? But it's also not a very precise question. We could have a legitimate disagreement on what they're really asking, what counts as a good answer. So think about that for a moment, and then just take turns talking about it. And I'll write things that people say on our Jamboard.
We only know the shape.
And we know that a green one is 1.5 grams. And we know 2 greens make a blue and 3 greens make a red.
So the red one would be like 4.5.
Yeah, the red one would be 4.5 grams and the blue ones would all be 3 grams.
Do we know if they're talking about the average weight or just the blue weight because they're the most common?
It could be either. So one idea is most common. If we did that, the most common is the blue. So we would say that 3 grams seems to be typical. You also mentioned average. Everyone remember the formula for average? Add them up and divide by how many?
How many numbers are?
So what's the total? 1, 2, 3, 4, 5, 6 times 3 plus 2 1.5s plus a 4.5. And when we're done with all of that, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 total. So what is that? 6 times 3, 2 times 1.5. Oops, helps if I turn it on. I'm getting about 2.8. Okay, there's one other way we can think about something that might be typical. So anyone have another idea? If not, I'll just share it. It's not suggested very often. Okay, so the last thing we can do would be get rid of the oddballs, the outliers. It's similar to most common, but most common sort of emphasizes the one thing that appears the most. Whoops, oddballs. Whereas this one, there might be several things that we're keeping. We're just getting rid of all the weird ones. In this particular case, it's still true that the greens and reds, there just aren't enough of them. So we'll get rid of them. And all we have left is the blue, which is also 3 grams. So these sort of agree, but not quite. And we can't really say from the sake of English language that one of these is more right than the other. We just want to be clear about which kind of typical we're talking about. Okay, let's keep going. If we changed it to this, it gets a little more interesting. You would expect that this has a higher answer than the others because we have these big, heavy blocks here. It's still true that if we said what's the most common, we would only talk about the blues, and it would be 3. It's still true that if we said let's get rid of the terrible ones that aren't very representative of the whole group, we would still have the blues. If we did the average where we add them all up, we're going to get a higher number. So the point of this are two things. First, there's this famous saying, there's three kinds of lies: lies, damn lies, and statistics. And people often use that quotation talking about how we can purposefully mislead people with statistics. You can see that in the news today. Lots of people arguing about how bad is this pandemic? How much should we shut down buildings? And everyone seems to have statistics to support their side. But it's also true that you don't have to be intentionally lying. Our exploration of typical is that, yeah, sometimes there's just genuine ambiguity. There's more than one way to talk about these things. And if you're not being precise, then I could say 2.8 is the right answer, or I could say 3 is the right answer. And it's not that I'm lying to you, I'm just thinking about typical in a different way. So to avoid that in the math class, we're going to use very careful words. So two kinds of averages. The mean is what we just did. Add up all the numbers and divide by how many. So let's actually finish this up. So the average that's called the mean. That's the sum divided by how many. Again, these were 1.5. These were 3. These were 4.5. And then what's the yellow going to be?
9.
9, right? Twice the 4.5. Or 6 of the 1.5s. Or 3 of the 3. Okay, so we have 2 of the 1.5s and 1 of the 4.5s and 1, 2, 3, 4, 5 of the 3s and 2 of the 9s, and we're going to add all of that up, and then at the end divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and whatever that is. So now I'm getting about 3.7 grams. Everyone else get the same on their calculators?
I got 30.8.
I think 3.7. Anyway,
I got 3.7.
so that's the kind of average we're most used to. And it's not the only kind of average though. So we'll use the word mean to say that's the kind we want. So the mean is commonly used because in most everyday situations, it does what we want. It tells us an answer that's close to what's most often, and it says what's most representative in a way that's meaningful and inclusive. So if I have a preschool classroom and the students' weights are on this chart, one weighs 34, 3 of them weigh 36, 2 of them weigh 37, and so on, then we can say what's the average weight of the students, and the mean would be an appropriate thing to do. I don't want to spend all this time adding, but I'd add them all up and I'd get to a certain number. There's 12 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I divide by 12 and we'd say 38 pounds. So having seen that math, the 38 pounds looks right. You can imagine that if I was to draw like a teeter-totter, oh, that's a terrible line, then it would balance on the 38. This one over here is sort of counteracted by the fact that there's others a little closer over here and so on. Our eyeballs are pretty good at looking at this kind of histogram and saying, ah, okay, the mean is in the middle. The mean is the balance point. Here's another one like that. So here I have 2, whoops, another 2, a 6, and a 10. If I add them all up together, what do I get?
20.
And then we divide by how many?
4.
You get 5. So 5 is the balance point, right? That looks right. None of them actually are 5, but that's sort of a number that represents what's happening in this picture. Okay, this kind of graph we just used is called a histogram. Let's talk about that a lot because they show up all the time in real life. A histogram is a bar chart in which each bar counts a different category of things. You could count how much people weighed. You could count what scores people got on a math test. So I'll open this one in a bigger window so you can see. So this was an actual test I gave many years ago. So at the bottom is the score, and going up is how many people got that score. When the categories are numeric, they will have a natural order. It would be a bad histogram if these numbers on the bottom weren't increasing like a number line. If we decided to put the 41 over here and the 34 over here and the 37 at the far right, that would be very strange. On the other hand, not all histograms have numeric categories. If we're looking at the population of different states or the income of different counties in Oregon or something, there's no inherent order to how the bottom axis goes. It's not like one country is somehow before another country on the number line, or one county in Oregon somehow. So you could alphabetize it or something, but that's a lot more arbitrary. The height of the bar is how many things are in each category. So the height is always a number. You can't have names of students or names of countries or things here because we're counting how many. Notice that each student has a piece of bar. So if I take this picture, I could, in theory, go back to my class list somehow and say, this score right here, right, that was whatever, Donna's score. And this score right here, that was somebody else's score, and so on. I don't want to leave Donna's name there. But teasing her that she's in this class, right? This one is some other student. They got a 96. They were the third student to get a 96, and so on. We could count how many students are in the class. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And we don't want to forget this because in real life, people will often summarize a histogram. Instead of showing us the whole thing, they're just going to do something like that and make some sort of curve. And again, with the pandemic going on, you've seen these kinds of graphs all over in the news, how many cases there are, or how many hospital beds there are, or so on. So don't lose sight. Just because somebody draws a curve, there's actual real life things being counted underneath it, holding up that curve. If we had the data, we could count how many things were underneath, just like we just did. This histogram was color-coded. This test sorted people into sort of Ds and Cs and Bs and As, but most histograms aren't. This histogram was also well designed. I was trying to show off that this test sorted people into grades. And there's a nice A clump and a B clump and a little bit of a gap, and then the Cs, and then a gap, and then the Ds. So I didn't have to worry, should this person get a D or a C, because there's such a big gap here between the Ds and the Cs. But if I make my categories different, then I have this exact same data, the exact same students, but this looks like a very different shape. Just because I've taken the categories at the bottom and changed them. Now each one holds 5% and they're starting at 48, whereas before each one held 2% and they were starting at 48. So the students fit into different categories, and if I change the categories, then it changes the histogram. So this is one way to lie with statistics. If I wanted it to look like my test wasn't sorting students more, then I would show this one and say, look, I'm not sure what grade to give this student. Is this like a B plus because they're close to this nice clump happening here? Or is this like an A minus because this should be the A's? And you know. So if you're trying to make a point, you can do it with your histogram clumps. Do these more at home. We're talking about specific students that might care very much about how this works with their grade. So the official name for these category things at the bottom are bins. So this bin is 58 to 63. This bin is 63 to 68. On the other one, this bin was 71 and 72. This was 73 and 74, and so on. So when you pick your bins, it changes the histogram, sometimes dramatically. Okay. We can talk about histograms and typicality together. Here are 4 different histograms. Which one looks the most like there's some sort of typical value going on?
C.
C. And most people are sort of in the middle. Most countries have the same income. I'm not sure what this is measuring, but whatever it is they're measuring, most of the data is happening sort of in these middle values. Some are more, some are less, but most of it is sort of this kind of stuff. Maybe this is how much rain you're getting in a certain location, and most days are about the same. Some are a lot more, some are a lot less. Who knows what it is? Okay, which of the 4 graphs is has less typicality? There's still sort of a little bit, but not as much as here.
D.
D, yeah, there's very little. There's less at the extremes, but it's not like there's a clump in the middle anymore. We can see that if we were to make a teeter-totter out of this, it would balance, but it's not really like these things in the middle are so representative of their sample as they were before. If we keep watching the groups spread out, A doesn't look like there's anything typical in the middle. It looks instead like we have 2 distinct trends going on, a big trend and a little trend. Maybe these are the rainy days and these are the summer or something like that. And then if the clumps spread out even more, we get to this one. So the extremes happen a lot. The things in the middle seldom happen at all. So maybe this is, I don't know, how many times people have traveled out of the country. Most people haven't done much international travel at all, or it's just something that's part of your lifestyle, and not too many people have done it kind of an average number of times. So there's a name for this. The name is standard deviation. This isn't deviant like weird kinky stuff. This is just deviation, meaning differently from what's typical. And there's a formula for calculating standard deviation, but it's too complicated for Math 25. We are not going to actually look at this. If you ever wanted to know the standard deviations, you can use an online tool. So as an example, if you wanted to check your work, then here's a bunch of numbers. You can hit copy and paste, put them in this online tool, and it will tell you the standard deviation for them. But all you really want to know is that standard deviation is how well things clump together. Histogram C had the smallest. These numbers were actually representative of each other. Histogram B had the biggest. It was like they were running away. They were the most deviant from the middle. So this helps you understand news articles. If they're saying, how much does social distancing help with controlling the spread of a pandemic? Then if there's a high standard deviation, it means that the results we've measured are actually meaningful. There's some typical thing happening. I'm sorry, a low standard deviation. Right? There's not much deviancy. They're all together with typical. A high standard deviation is your experiment is bad. Your data isn't actually following any trend. Everything is completely unpredictable. So low standard deviation means predictability. Lots of things are typical. High standard deviation means everything is running away from what's typical. It's all kind of way out there. So that's a good word to know just to be educated, but we're not going to do the math about it. Okay, questions on mean before we go on to median?
Just a refresher, means is sum divided by how many?
Yes, mean is sum divided by how many. Okay, now if I look at the same classroom and my students say, wait a minute, this is take our stuffed animal to school day. We want to have 3 stuffed animals who weigh 1, 1, and 2 pounds as part of this thing. Oops. So way down here is 1 and 2. And so we have 2 things at 1 and 1 more at 2. I could find the median, just like we did before. So we could add up all these numbers. Did we leave out the 1, and the 2? No, I did put it there. Okay. I don't want to bother to count everything out, so I'm just going to steal my thing here. So we did the sum. And then divide by how many. So now we get a median of 30. So if I was to try and draw this as a teeter-totter, a balance point of 30, there's nothing here that actually weighs 30. All the kids weigh more. The stuffed animals weigh much less. These oddball cases messed us up. Do you see what happened? The sum got bigger by just a tiny amount compared to this other one. But when we divide by how many, we divided by 15 instead of 12. And that made this number get much smaller. So we shouldn't treat these as if they were important as the preschoolers. Questions about that before I go on?
Yeah, I'm not clear.
Oops. Let me go back up to the other one so I can flip back and forth better. So when we had only the preschoolers, their weight was 453. And we divided by the 12 of them and we got 38. And 38 really was a good representative number for this crowd of preschoolers. Only one of them was 38, but that's fine. If I bought life vests for a 38-pound child, we could go canoeing or something like that, right? It represented the group in a general way. On the other hand, if we put in a 1, and a 2, that made the total only a tiny bit bigger, from 453 to 457. But we divided by a substantially bigger number. We went from 12 to 15, and that made the answer get much smaller, down from 38, which actually looked like something, to 30, which was in between the groups. The preschoolers were all much more than 30. Their toys were much less. So 30 doesn't really show us anything meaningful. We need a different kind of average to deal with this situation.
So you have.
So I'd what?
So how did you get the divide by 15? Is that?
Because we had how many things were in the room? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Okay, thank you.
So the tool to deal with that second kind of situation, where there's some oddball things that we really shouldn't treat as well as the rest, is a median. So the median, you first sort the list of numbers in order, and then you pick the middle number. If there is no middle number, that means there's an even number of values. So what do you do if there's nothing in the very middle of the list? Well, you take the two values most in the middle and then do the mean of those, add them up and divide by 2. So now what we're doing is, let me copy this again. We're taking that list and sorting it. So 1 first, another 1, a 2, and then the 34, and then the 336s, and so on. So I take my sorted list, and then we go into the middle. And we say 1, 2, 3, 4, 1, 2, 3, 4. Let's keep going. Another 2. Okay, so these 2 are our middle values. Since we didn't have a single 1 in the middle, then we have to average them. So 36 plus 37, then divide by 2, and we'll get 36.5. So the steps were sort the list, pick the middle, and if two middles, then take the mean, sum divided by 2. Everyone okay with that process? I'm going to do another example problem in a moment.
Okay.
So let's look at what happened. Before we stuck in the silly stuffed animals, then the average was 38. Now we have another number, we're calling it a different kind of average, and it's 36.5. So we've gone down a little bit. But that's still a better number for this whole group, including the silly stuffed animals, than when we had 30 in the last slide. So you can see that it doesn't matter what any of the numbers are except for the middle. If these were also stuffed animals, it wouldn't matter. We're kind of tossing out the oddball ones. The only ones that really matter are the ones in the middle. So if, I don't know, I'll pick on Cade. So in Cade's neighborhood, Bill Gates moves next door and builds a giant mansion. Then that's not going to make the property value of the neighborhood suddenly jump up a whole lot. If we added up the property values and divided by how many, it would look like Cade's house suddenly is worth a lot more. But the oddball case doesn't actually count as much. If this 41 was really a 141, because we put one of the teachers in, it doesn't matter. It's not going to change the median at all. That the oddball cases get skipped over by this process. So when we're talking about demographic things, we don't want the extreme cases to get in the way, this works. What's the average salary in Oregon? We don't want either, you know, the CEO of some giant company or the homeless people to affect that number much. Okay, let's do more. I'm going to open a homework to get an example. Random. Okay, so try these. I will do them in a moment. Find the mean and median of those 6 numbers. And then it's 11:30, so we'll be done. Okay, everyone get the same two numbers? Thumbs up on your screen or something if you did. So we'll talk more next about why you would want two different things, but you've gotten an intro to them at least. Okay, any other questions before we're done? Thank you for your time. Have a great weekend.
All right. Thank you, David. See you Tuesday.
See you Tuesday.
Thank you.
Thank
Thank
you.
We do have that study session tomorrow if anyone wants. And if you need other times, let me know. And I will get back to you as soon as I get the photocopies done about how to get printed things to the people who wanted that.
What time is the study session
And
tomorrow?
what was our
Tomorrow, 3:30.
Thank you.
Yeah. 3:30.
I'm checking. Does
Oh,
it?
okay. Hi, Adrian.